Good day, learners. Welcome to Technical Mathematics lesson. My name is Matulela Takomu, and this lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Grade 11s, please note that today we are going to be dealing with the topic logarithms. And the subtopic of logarithms, we will be focusing mainly on logarithmic equations. So now, looking at our lesson objectives, at the end of this lesson, learners should be able to, the first one, you should be able to solve equations using definitions of logarithmic, and we must also solve exponential equations using logarithmic, and you also need to be able to solve logarithmic equation involving the logarithmic laws. So now, without any waste of time, let's look into some of our basic concepts that we need to be focusing on. And remember, this type of concepts, we do have them in the formula sheet, which is the information sheet there. They say we must now solve equation using the definition of logarithmic. So now, in this case, we are saying, if you have, in a case, y, let's just change our pen, y is equal to the log of base a of x. Remember, a is the base there and x is the number. Then, when it's like this and we want to solve for x, we move it to that way. What happened here is that your base will now go to the left hand side and becomes the base on the left hand side, and then y will become then the exponent, like what happens here. The a base of a, it becomes now the base on the right hand side, and then your y becomes the exponent. So we will be talking about that more so that learners can understand on how to solve logarithm using the definition. We can see here it says what you have as a base, it will then be the base on the other side. And what you have there, it will now tend to be what? It will now tend to be the exponents. And then now there are restrictions there. It says a, it must always be greater than 0, which a, the one of the base. And then it can be 1, and y it can be 0. Y it can be 0. So remember, if ever in definition we're saying if you have the log of 1, it will be 0, and the 1 log, it can be 0. So now we move forward to look into how to solve other equations. So in this one, they are saying you solve exponential equations using logarithms. So now you have a case where now you have an equation where it's a plus b, and when now you want to solve for the equation, you need to introduce the logs. So in that case, you will find that, for instance, you will have for x to the exponent of 2, it's equal to 5. So in this case, you can see that when we were dealing with exponents, you knew that you can only say the base need to be the same for you to equate the exponents, or the exponents needs to be the same for you to equate the bases. So in this case, you can see that the base on the left hand side and the right hand side, they are not the same. So that's where now you can introduce the log. So that's basically what it means here.
Recording in progress.
Where you have the equation where the bases are different, but you need to solve for x. Then what you do, you will introduce now the logs base side, both sides. So now we go to the third one now, where it says solve logarithmic equations using logarithmic laws. So now remember from the basic one where we're dealing with product of laws, if you add two logarithms that have the same base, you can combine them into one by doing what? By multiplying the number of the logs. Correct? Then if ever you have the log that have the same base subtracting each other, you can also combine them to make them one by division. So in this case, you can see that addition goes hand in hand with multiplication, and subtraction goes hand in hand with division. So those are the basic rules that you need to put in mind as we are dealing with the equations. So we have activity number 1. In activity number 1, the question says solve for x in the following equations. So let's see, how do we deal with such equations? Remember, we are solving for x. It means at the end of the day, we must make x the subject of the formula. In this case, our aim is to get rid of the log. But how do we then get rid of the log? Like I indicated, that the base here will go and push your 4, then x will become the normal base and 4 will become the exponent in the form of 16 is equal to x to the exponent of 4. So that's how you remove the log. That's how you get rid of the log. Then now, when we're solving this one, we can simply say, okay, 16, we get the prime factors of 16, then it will be 2 to the 4 is equal to x to the 4. Now we can go back and apply our rules of exponent, where it says if the exponents are the same, then we can equate the bases, then your x will become 2. So it is as simple as ABC. What you need to know is how to apply the definition of logs. When we move forward, we still apply the same definition. Remember, in this case, our aim is to get rid of the log. Then we apply the very same procedure, where you're saying 3 will go and push 4. Then now we're going to have x squared is equal to the base of 3 to the exponent of 4. So now in this case, we can move further and say x squared is equal to, if you say 3 to the exponent of 4, you now get what? You get 81. Correct? And remember, in this case, you can have two ways of dealing with this. The other one is to say is 81. Then the other one is to introduce the square root both sides, knowing very well that x is going to be plus minus 9. Or you can say x squared is equal to 81. Then you transpose your 81, it becomes x squared minus 81 is equal to 0. Then you know that we can factorize using difference of two squares. So you're going to bring your x's together, and then because it's difference of two squares, one bracket will be negative, the other one will be positive. Then from there, they will share what? 9, both of them. Then x plus 9 is equal to 0, or x minus 9 is equal to 0. Then we know that our x's are going to be like that. So that is another format of how to deal with that. Remember, you need to understand mathematical operations for you to perform such. All right, we go now to the third one. Another thing that we also need to understand in terms of logarithms is that as we go and you are given the log of a, and then now you are not given the base, we can always assume that our base is what? Is 10. We can always assume that our base is what? Is 10. If you are not given the base, you assume that your base is 10. So in this case, how do I deal with this? There are two ways that I can deal with this one. The first thing I can say, let's get rid of 3 over 2. We divide both sides by 3 over 2. Then as 3 over 2 divide 3 over 2, then the log of x it will be. So now we're saying 3 divided by 3 over 2, you find that your answer there is 2. But we said that the base, we assume that is 10, and how do we then remove that base? It will go and push that one there, and we have x is equal to 10 squared, whether x is going to be your 100. Correct? Then we can test whether x, if x is 100, then we are going to reach a 3. So we're going to say 3 over 2 log of 100. Then if we punch that in the calculator, 3 over 2 log of 100, then you realize that your answer there is 3, which is equal to what we have there. Then you have solved that successfully. So we go to the next activity. We are solving for x in the following equation. We can now start by dividing both sides by 2. 2 divided by 2, we're going to still have log base 3 of x. It's equal to log 3, because 6 divided by 2 is 3. Then we apply the basic operations that we are used to by saying we remove the log. As we remove the logarithms, what happens? We have x, it's equal to 3 to the exponent of 3. X, it will be 27. Or another learner can say 2 log base 3 of x is equal to 6. They can firstly start by taking these 2 and bring it as an exponent, and they will have log of 3x squared is equal to 6. And as we take out the log, then this will happen. X squared is equal to 3 to the 6. So if you say 3 to the exponent of 6, you're going to have x squared, which is equal to 729. Then we introduce the square root, x is going to be. Then you introduce the square root of 729, you are going to get 27. So those are two ways of dealing with this. As long as your operations of mathematics are correct, you will definitely arrive at the same answers. So that is how we firstly deal with the first activity. Now we move forward now and we look into the second activity. This activity is where now we have to now introduce the logarithms because they are not there. Now we agreed that as we were solving in exponent, you find that you have x squared is equal to 4. Then we realized that x squared, it can be written as 2 to the 2, then x will be 2. Or we dealt with it when we have the base of 2 with the exponent of x, it's equal to, for instance, let's say 8. We know that we can make the base the same here by saying 2 to the exponent of x is equal to 2 to the 3, as we're looking for the prime factors of 8. Then therefore in this case we can say x is equal to 3. Why were we doing that? Because we know that the bases are the same, then we can equate the exponents when the bases are the same. So with logarithms, how does it help us? It helps us in a way that in this case, dealing with logarithms, you can see that you have 5 to the exponent of x minus 3 is equal to 0. So if I say 5 to the exponent of x is equal to 3, now I'm transposing this 3 to the other side. I can apply the very same method that I've applied here. Why? Because my bases are not the same. The bases are not the same. On the other hand, I have 5. On the other hand, I have 3. So that's where now we say you must introduce the logarithms. As you introduce the logarithms, that's how you introduce them both sides. Then we apply the rule that says, or the law that says you can still multiply the coefficient by x. Then x is going to be log of 5 is equal to log 3. Then we divide both sides by log 5 and also divide both sides by log 5. Log 5 divided by log 5, therefore x is going to be, so now if you say log 3 divided by log 5, then you will find your answer as 0,68. 0,68 then is your answer. So you can see that here we apply the logarithms. We introduce the logarithms because of the bases that are not the same. If the bases were the same, then we're gonna easily deal with exponents. So we move forward now. In this case, we're having 3 to the exponent of x minus 2 is equal to 12. Then in this case, you can't divide both sides by 3 because 3 is carrying the unknown variable. So the best that you can do is to introduce the logarithms both sides. Then the method that you are going to apply here is to take this whole thing and we multiply by it there by the coefficient. So it's going to be x minus 2, the log of 3 is equal to the log of 12. So in this case, we can now divide both sides by the log of 3 and also that side by the log of 3. Then what happened from there, you know that 3 will divide by log 3 divided by log 3. Then you will have x minus 2 is equal to. So now if you take out the logs and you say log of 12 all over the log of 3, you realize that you're going to have 2,26. 2,26. Then we transpose your negative 2 to the other side is going to be x is equal to 4,26. Therefore, that is going to be your x. X is going to be 4,26 because 2,26 plus 2 is 4,26. So that's how we now deal with the second sub-question of solving the equations there. So I hope it was clear. We move forward to the next one. In this case now you can see is different from the previous one. In the previous one we only had 3 as the base, hence we didn't multiply both sides. So now looking to this one, we are having 2 multiplied by 3 to the power of x, or to the exponent of x. So the first thing that we can do here is to get rid of 2, because 2 is not carrying any unknown variable. So 2 divided by 2, we're going to get 3 to the exponent of x, it's equal to. If you say 19 divided by 2, you get 19 divided by 2. Then we introduce our logs. We now apply our rule where x multiplied by log 3 is equal to the log of 19 over 2. Then we divide both sides by the log of 3, and we also divide both sides by the log of 3. Then x will be, because this 3 will divide by that 3, then the log of x will be the log of the log of 19 divided by 2 all over the log of 3. Then there we are going to talk about x, that is 2,05. When you run it to 2 decimal place, that's how you are going to solve that thing. Then remember, all the time you can test it. If you have 2 multiplied by 3,05, or 2,05. Then now you will have 2 multiplied by 3 to the exponent of 2,05. You will see that you get 19. The answer that you get there is 19,0102. So we can approximately say it is really 19. Correct? Which is what we have there as our answer. To the next one, here in activity 3, we can see that we are now having 2 logarithms, correct? And then we are equating them to a certain number. Now it's an equation. Remember, we used to have them like log of maybe 50 plus log of maybe, for instance, x without an equal sign. So now we are equating them to a certain number. Then in that case, what we do there, we now move forward to what we know, to saying if the log of base a of x plus the log of base a of y, we can now combine them and say the log of x multiplied by y, because now the log and the bases are the same. Then we can multiply the numbers there. So this is the method that we are going to apply. Remember, I said when you are not given the basis, we always assume that the base is 10. So now what we're going to do here, we're going to have the log base 10 of 50 multiplied by x is equal to 2. Then now we get rid of the get rid of the log. The 10 will be the base and the 2 will be the exponent. So we're going to have 50x is equal to 10 squared. Then we're going to have 50x is equal to 100. Then we divide by 50 both sides. Then 50 cancel 50. Therefore, x is going to be 2. So now your x in that case there is going to be 2. So if you take the log, you write it like that. You say the log of 50 plus the log of 2. Then the answer there, it must give you 2. You can test that using a calculator. So it's the log of 50 plus the log of 2. The answer there will become 2. So we have answered our question successfully there. Then we move to the next one, little bit tricky because now you can see that the log is there by the base. And all the bases are not the same. So you can't combine them because the bases are not the same. It means in this case you must work with each and every term separately. But how do you do that? You're going to have the log of x 25 plus the log base 2 of 2 to the 3. Remember, your coefficient, your prime factors of 8 is 2 to the exponent of 3, minus, remember the deduction that says if the log, the base and the number are the same, then it's 1. So now here in this case, we're going to have 1 is equal to 4. Then now we come again and see the log base x of 25 plus, now we take this 3 and we multiply the coefficient, it becomes 3 log base 2 of 2 minus 1 is equal to 4. Then you can see that this method that we have applied here can also be applied in this case. Then you're going to have log base x of 25 plus 3 into 1 minus 1 is equal to 4. Then you can see that now we're going to have the log base of x of 25. Then when we add the 2, you're going to get plus 2 is equal to 4. Now what we can do here, we can now transpose these 2 to the right hand side. Then we're going to have the log base x of 25 is equal to, if we transpose that 2 will become negative, then 4 minus 2 is 2. Then now we're going to take this x and it will push the 2 there. Then we're going to have 25 is equal to x squared. Then now that's where you can introduce the square root. Then x, it will be plus 5. Remember, it can be negative, right? It can be negative 5 because obviously you're going to have plus minus 5. But remember the base, they said that base, it can only be greater than 0. Correct? So that is 5. That's how you solve that one there. So we move forward now. We are having a situation like this. Even in this case, we must make sure that we make x the subject of the formula. But there is something interesting there in the left-hand side, of which we can work with the left-hand side up until we reach a point where we can remove the 3 by dividing both sides by 3. So what do I mean by that? Remember, you can work with the log base 2 of 1 over. If you get the prime factors of 128, you will realize that it's 2 to the 7. Then we are going to say 3x. Then we can write it in a negative exponent by saying log base 2 of 2 to the negative 7 is equal to 3x. Then now we can multiply this negative 7 there in front, and it's going to be negative 7 log base 2 of 2 is equal to 3x. Then it's going to be negative 7 into 1 is equal to 3x. Therefore, negative 7 is equal to 3x. Then we divide both sides by 3. 3 cancel 3. Therefore, x is equal to minus 7 over 3. So that's how we deal with that one there. Okay, we move forward to the second one. the fourth one, sorry. With the fourth one, we can see that the base is there. They are the same, correct? But before we can combine them, we must firstly transpose this -3 to the right hand side. So we're going to have log base 2 of 1 minus x plus log base 2 of 5 plus x is equal to +3. Because of this positive, then I will multiply the 2 bracket, but I will still have log base 2 of log base 2 of 1 minus x multiplied by 5 plus x is equal to 3. Then we apply our rule of removing the log. Then this is how we're going to do it. 1 minus x, 5 plus x is equal to 2 to the exponent of 3. Now we apply the very same basic of FOIL method. We have 5 when we multiply 1 times 5 plus 1x minus 5x minus x squared is equal to 8, because 2 to the exponent of 3 is 8. So we're going to have negative x squared when we're putting in the descending order of x minus 4x plus 5, then it's equal to 8. So if I want to put it properly, I can say 0 is equal to x squared plus 4x plus 3 is equal to 0. So basically what I've done there, I just took everything from the left hand side to the right hand side. That's what I've basically done there. Then 0 is equal to, then this one we can factorize, saying x and x plus 1 plus 3, because factors of 3 that can give you, factors of 3 that can give you 4 is 3 multiplied by 1. 1 multiplied by 3 is 3. 1 plus 3 is 4. So basically x is going to be -1 or x is going to be -3. So that's basically how we are going to solve that particular question there. Okay. We move now to activity number 4. And activity number 4 is the one that you find namely in the exam, most of the time in the exam. But we need to be careful when we are dealing with this one. Is the repetition of the activity 3, but now you can see that we are having negative, and then the base are not given, so we conclude that, or we assume that our bases are 10. So we're going to have log base 10, because division is going to be x plus 2 divided by x. Correct? Remember we had log base a of x minus log base a of y. We said we can write it as log base a of x divided by y. So that's what we did there. Then now this is equal to 1. Then now what we do, we get rid of the log. We're going to have x plus 2 all over x. It will be 10 to the 1, which is 10. But then what do we do here? We can simply divide here by 1 and cross multiply. We are going to have 10x is equal to x plus 2. Remember, 10 multiplied by x is 10x. X plus 2 multiplied by 1 is x plus 2. Then we can transpose that one to the left-hand side. Then we're going to have 10x minus x is equal to 2. Then we're going to have 9x is equal to 2. Then we divide both sides by 9. Sorry. We divide both sides by 9. 9 cancel 9. Therefore, x is equal to 2 over 9. So that's basically how you can solve that one. Then, for you to test it now, you can put it inside the equation. Where there is x, you can substitute 2 over 9 to test if the answer is going to be 1. The answer is going to be 1 when you take 2 over 9 where there is x. If you substitute 2 over 9 where there is x, the answer is going to be 1. So now, in this case now, you can see that we are having an expression where, or equation where we have log base 2 of x plus 3 minus 3 is equal to minus log base 2 x minus 4. So here we will now group the like terms together, which is log base 2 and log base 2. How do we do that? We are going to transpose this one to the left hand side and also negative 3 to the right hand side. That is the transposing that we are going to do. So we're going to have log base 2 of x plus 3 plus, because it's negative, it will be positive, log base 2 of x minus 4 is equal to positive 3. Then we can combine them and say log base 2, because there is positive, they're going to multiply each other. Then we get rid of the log. Then we're going to have x plus 3, x minus 4 is equal to 2 to the 3. Then we're going to have x squared minus 4x plus 3x minus 12. So it's equal to 8. So basically we're going to have x squared minus x. So if I transpose this one that side, it will be minus 20. It's equal to 0. So now we are going to factorize that. Then it's x and x. So factors of 20, that can give us 1. Remember, multiple of 20 is 20 multiplied by 1. Or it can be 10 multiplied by 2, or 5 multiplied by 4. So you can see that the one of 20 multiplied by 1 and 10 multiplied by 2, they don't give us 1, only 5 and 4. So we're going to have 5 and 4, which is positive and negative. So x is going to be positive 5, or x is going to be negative 4. So those are the two numbers that are going to get there. Then you will substitute them so that you can test which one is going to be suitable for this solution. Then we go to the third one now, where it says we must solve for x as well. But you can see that in that case, we have log base 4 of x plus log base 4 of x minus 6 it's equal to the log of 5 or log base 5 of 25. So in this case here, what we can do is to combine them to saying log base 4 of x multiplied by x minus 6, it's equal to, on the other side we can solve it manually there. Then we know that in this case we're going to have log base 4 of x minus 6 of 2, because we're going to have 2 log base 5 of 5, which is 2 into 1, that is 2. Then now this one here, we're removing the log, we multiply again, we're going to have x squared minus 6x, it's equal to 4 to the 2, then x squared minus 6x, it's equal to 4 times 4 is 16. So we're going to take this one here and transpose it. We're going to have x squared minus 6x minus 16 is equal to 0. So when we factorize x squared minus 6x minus 16 is equal to 0, we open the bracket, then we're looking into the multiplication of 16. Factors that we multiply, they give us 16, and we add them, they give us 6. We can agree that is going to be 8 and 2. 8 times 2 is 16, and 8 minus 2 is 6. So this one is going to be negative, this one is going to be positive, then x is going to be or equal to 0, then x is going to be negative 2, or x is going to be positive 8. So we can also test that one, which one is going to be suitable for this equation then. So this is how we're dealing with exponential equations. This is how we're dealing with logarithms equations, sorry. This is how we deal with logarithms equations. And then this is the end of our lesson. I hope you have learned a lot in dealing with logarithmic equations. Then you must practice more and prepare for your exam. Thank you.